Ioannapot, Budapest. Correct. I'm glad it was correct. The last time I tried this was in Chinese, so I guess it was more difficult. I like being here. Like I think it's the third time I'm here in Budapest, and fourth time in Hustev. So I like being here. I really like this conference. And we will talk about testing. And in this talk, we will talk about testing robots. So we already had a wonderful start with an amazing keynote. And I believe this topic is a little bit exciting and interesting for all of you. My name is Mesut DURUKAL. I'm originally from Turkey, but nowadays I'm living in Japan, and I'm coming from Japan. So most probably this is why I will talk about some robots. I'm leaving some socials here, so please do not hesitate to reach out. And I know it is a little bit short to talk about everything in detail. So I'll give you a brief understanding of how warehouse automation systems work. And if you still have some questions and if you are curious about the topic, then you can reach out to me from any socials. So what can you expect from this session? First of all, I will make a briefing about the system, like how the system works, how the warehouse automation systems work with robots. There are some moving robots around, autonomous mobile robots, like human-sized robots. And then I will explain how we are testing this and the test automation system that we are using to test such a system. And in the third section, I believe this is the most important one. We will go over some problems and, of course, the solutions to cope with these kind of problems. And again, what you can expect from this session is, this is a trending topic. So there are warehouses everywhere in most of the countries, and there's an automation system. So you might be testing such a system now or even in the near future. Or even if not, most of the problems that we will talk about are some common problems that can be encountered in any testing environment. So I guess the first problem, which is the biggest one, is very specific to this product, but the rest of them you can see in any testing environment. So we will go over 10 different problems and some proposals to cope with these kind of problems. And then I wrap up and we will close the session. So this is what I expected before moving to Japan. It was around 3 years ago. This was my imagination, because when you first say Japan, I come up with some high-tech systems, some robots, digital systems, and it came true. Like the first picture is from Shibuya Square, which is a very famous crossing. I'm passing through like every week to go to the football stadium where I play. And you can see in some movies, like it's true. And the other pictures are all true, happening in some fairs or developed in some different projects or products. But as a fun fact, normally, in Japan, it's a super traditional country. In daily life, people try to avoid technology as much as possible. Like in our house, we don't have a washing machine. You can think like that. This was just a fun fact, but still, the previous image was true. So high-tech solutions, products are being developed. And warehouse automation system is one of them. So let's a little bit talk about that, what kind of systems or products are being developed, and how we can test, how we can ensure the quality in such products or the components of the system. So first of all, let me a little bit briefly explain you how it works. So we are talking about a warehouse automation system, right? There's a warehouse. There are some different racks placed in different aisles. And in the racks, there are different items. So whenever there's an order, we have to pick. For example, I have to deliver, let's say, 10 different smartphones to a company. So I have to pick those items from different locations, because those smartphones might be in the first rack or maybe in the third aisle in another location. So I have to go to different locations and pick those items and then pack for the delivery. So this is the system. And as we can see, the main component of this system is robots. Because normally, this picking system can be done by manual operators, some manual human beings. But we assist these operations by the robots. So robots will automatically move. In some systems, robots has arms as well. Even the picking is done by robots. But in this system, robots do not have arms. So the picking should be done by human operators. But robots will assist them to go to the next location. What does it mean? I will explain in a minute. And we already saw robots are one of the main components in this system. And on robots, there is a screen. There's a UI, user interface. This is where the human operators interact with the system. Like they are clicking the buttons, or they are selecting some items. They are reading the instructions. So robot UI is the main interface, where the human operators interact with the system. And then there is the inventory management system, which is basically the IMS, where the items are managed. Because, you know, there are different items. And normally how we operate is we pick the item and place on the trays of the robot, right? But sometimes the size can be very big, so we are not sure how many of them can fit in a tray. So I need the size information. So this is where I will collect this information. I will send an API query. So IMS has some APIs. I will send some GET queries, and I will learn some information like the dimensions, size, weight, and everything about the items. So this is another interaction point that I have to test, another interface that I have to test. There is the HPC. Like for us, we have a company located somewhere, and there are several customers. Like for example, in the same city in Tokyo, there is one company, which is our customer, and there's another one in Osaka, in another city, so it's another company, which has another warehouse somewhere else. So all of those are different customers. So those are edges, edge nodes for us. What does it mean? In every warehouse, there is a central PC operating the whole system. But for us, from looking from another above level, there is the cloud platform where we can send the updates to each node. For example, whenever we have a software update, we can update from remote, from the cloud platform. This is the cloud PC. And in every node, there's an HPC, which will operate the local operations. And this is the testing system, testing environment. On the upper side, you can see the system under test. I just explained the interfaces, like we have a UI on the robots, we have an API on the IMS, and in between there's a system PC, HPC, operating the whole system. And from the test framework, you can see the box in the below. We are sending some queries and reading information from these interfaces. And we are using different tools, like in Python language, or like as the testing framework, we can use Selenium for doing the UI operations, or for our APIs, we can use different libraries or frameworks. This is the very brief depiction of the testing environment and the test automation system. And I wanted to show you a test environment that we have, because imagine, like, we have a customer and we are preparing a product for them, and it's far away. We are living in Tokyo and it's in Osaka. It's like 300, 400 kilometers away. So without testing anything, if you just right away go to the real location, the production environment, you might face some issues, right? So what we do is first, we prepare a simulation environment, like we call it as alpha testing. In literature, it might be named for different purposes. But for us, alpha testing is the environment where we test inside our building. We just simulate the real environment. The purpose is just to do kind of smoke testing. Like if we have any major issues, of course we will fix it and then go to the real environment, just to avoid having any surprises when we go to the real location. And this is a very simple test code. So this system can be automated, the whole testing activities. This is a very simple test code. So we just sent some queries to create orders. And then we can just automate the UI actions on the robot UI. Because it is just a UI application, right? It's running on a robot, okay, but it can run on any platform, like on a Windows machine, on a Mac machine. It is just an UI application. So we are just doing the UI automation. So this is how we do the test activities, testing activities. I will visit this slide one more time to show there are some good practices we are applying on this test code. At the end of presentation, I will visit this again. For now, just take a quick look, and I will show what kind of good principles we are trying to apply on this code. Let me a little bit talk about some problems we have. First of all, most probably the most important one, the testability of the system itself. What is the goal? What is the purpose? To optimize the operation, right? For example, normally, think about a system where we don't have any robots. Normally, all operation is done by human operators. So normally they are moving around, they are picking items, and they are carrying by hand. So our purpose is to minimize the traveling distance. Because in this way, people will not move too much around. They will not lose time. They will not spend too much effort to fulfill the operations. So basically, the very basic problem is minimizing the traveling distance. So in literature, it's called as the traveling salesman problem. And it can be solved in some mathematical ways. But thinking from the functional testing point of view, it's not that much straightforward. Because imagine, we are not talking about only one robot. In the warehouses, there are, I think it was in one of the slides before, there are a number of robots waiting for operation in aisle position. And whenever I send the order them to go, they all start moving around. So there are a number of robots moving around, and they are visiting different places. So how can we ensure that the travel distance is really the minimum one? Let me illustrate this with a very basic scenario. This is super simple, just to give you an understanding of this. For example, if they pick the first pattern, it's in red colors, they will first go to the third item, and then second, and then one, and then go to the delivery point. This is the first option. And in the second option, they will choose another pattern, first item 1, 2, 3, and we can see the difference, like almost, I guess, 1/3 difference will affect the performance and the optimization. So this is the importance of minimizing the traveling distance and selecting the best pattern. And remember, there can be some ongoing processes as well in the meantime. Some robots might be operating the previous order. Whenever a new order comes, then they should be assigned to the new order. So this is a difficult problem. And how we try to cope with this problem is, of course, we are doing some longevity tests and performance tests. For example, we just place several orders, and we start calculating. Let me go back to the previous slide. There are some performance metrics here, order completion time, and moving distance. We track these metrics, and at the end of the day, like after completing a lot of orders, we check this and compare these metrics to be able to do a benchmark. For example, what if we just let some human operators do the operation, or if we place 3 robots, what happens? How the metrics will change. And if we place 3 more robots, like in total 6 robots, then how will affect these metrics? So this kind of benchmarking we use to have an understanding of the performance of the system. And this is how it looks. This is just a small recording, just to give you an explanation or understanding of how a real warehouse system works. Then, problem number 2, hardware. We have a hardware, right? Rather than testing a system where there is pure software, in the system there are some hardware. So it's really difficult to test or even automate. So what we do to test these kind of systems is using simulation environments. So we use robot operating system to build our simulation environments. And by using them, we can already generate the signals going through different hardware components and the interfaces. And a similar problem is AI. AI is nowadays everywhere, right? It's in our daily life. Like whatever I'm using, like even if I'm using media on a smart device, TV, there are some AI applications. It's recommending me some different proposals. There are some models being generated. So which means we are very likely to have some AI components in the system that we are developing. So it is the case here as well. How we utilize in this system is, when robot is moving, there's a camera, so it recognizes the object in front of the robot. It might be a human, so it might be a moving object, or it can be any other obstacle, like it can be a box, which is not moving at all. So which can be a visual recognition problem. We have this kind of AI components, and how we can test this is, of course, while building this machine learning model itself, you can evaluate the performance of this system. But after delivery, in terms of functional testing, it's not that much easy. So how we do is just performing some experiments. Like I just stand in front of the robot and observe how it behaves. Of course, we are supposed not to crash, because there are some urgent brake systems as well. But we just see if it is recognized accurately or not in these ways. Another problem, which you can see in any systems. Now we are talking about non-functionality, right? It's not only the functionality. When we are talking about quality, there are different aspects and dimensions, and usability is one of them. And particularly in this system, we are talking about efficiency and optimization, right? And suppose if the system is not easy to use, if, for example, operators are struggling to find where the buttons are, it means they will lose some time to use the system if it is not usable. So how we ensure this is, we try to directly communicate to the end users and try to understand their feeling about using this product. We try to collect some feedback from them. Another problem, which is a similar one, again, another non-functional dimension, which is the recoverability. What happens if something happens, which is unexpected? Like if one of the robots suddenly stops, what will I do? It is an unexpected situation, right? Normally, it should not happen. But what if it happens? How the system will react in this kind of situation? This will be kind of recoverability in such an unexpected situation. If the system is capable of handling this situation, like another situation might be the communication problem, right? If suddenly robots stop communicating their location information, the system should be capable of managing this. Like, I don't know, it might collect the data offline, and whenever the communication is built again, then it can send all the collected information once again. So these kind of non-functional testing are helping us to ensure the quality in such a system. And reproduction of the issues. In any automation system, whenever you run your pipelines at night, some tests will fail, right? And in the next day, when you go to the office, you will see the failures, and you have to understand what happened. Otherwise, you cannot report a bug, or you cannot even do a root cause analysis. So what we do is we collect several evidences. Like, of course, all the screenshots and even a recording. Like, in the modern test automation frameworks, there is a chance to collect some traces. So in the system, we collect all the evidences. And a module in a robotic operating system, which is called as rollback, you can replay all the recording. And you can have an understanding of what happened during the execution. Moving on, customized requirements, which means all the warehouses several custom requirements. Everyone has a different size, different number of robots. So how we do is, of course, we do not repeat all the test automation activities. So we just build reusable tests in the first place. So even if the configuration changes, since I exclude these kind of configurational settings from the test code itself, I just manage the configuration and I just run the same test code on several environments. This is the reusable tests. And I will combine this domain knowledge with the next problem, which are very similar. In the specific domain, you have some certain level of knowledge. You have to know what the end users are willing to see in this system. So what we do is we, of course, prepare several onboarding activities, onboarding documentations, and we even visit the real testing environments to see what is going on and what are the end users are really following to perform their actions. And final problem number 10, maintenance. Continuous maintenance. We do in all our test automation systems and frameworks and environments, right? Because we have to, on this image, why did I put this? You can see a duplicated image. There are two same images. I guess it is the Mona Lisa one. Whenever you want to change, which means you want to update your test code, you don't have to, I'm just wrapping up, you don't have to duplicate this image if you already use or move this to a reusable resource. So this is relevant to the previous one that I just told, right? So building reusable test code by moving all this repeated code to a reusable resource. All right, so this is the code that I shared previously. So there are some good, I cannot say best practices, but good practices that we can talk about. For example, annotations or tags to collect similar test cases together to construct some suites. And again, remove or avoid duplication to build reusable code or reusable resources by using some maybe helper classes or those kind of resources. And some patterns like page object model or any other pattern which is applicable to your framework. And finally, of course, smart weights. This is all we use to avoid just dummy weights, right? So I'm wrapping up. I'm at the end of my presentation. So we talked about 10 different problems. This was particular to a warehouse automation system, but most of them you can see in any other environment as well. Those were the testability issues, hardware issues, and hardware and AI issues, and some non-functional aspects. And we talked about reproduction of the bugs and doing a root cause analysis, and then customized requirements to build some reusable test environment, and domain and technical stack, which is specified to this product, so reserving some time for onboarding the members, and finally doing the continuous maintenance, which you should do for any kind of test automation to build a reliable and maintainable test code. So thanks a lot for listening to me, and I hope you enjoyed the rest of the conference. Again, I'm leaving some socials, and last call for action should be, beware of your problems. There will be several problems in whatever you are doing, but please beware of them, develop some solutions, share to others, and do not be afraid to try something new. Just try. If it works, then adapt to your daily routines. Thank you very much, and enjoy the conference.
Thank you. Okay, let's quickly see. We have 2 minutes for the questions. How big is the most fun, and what is the most frustrating thing testing robots? So why is it fun, and why is it frustrating?
It's fun because the product itself is really exciting and fun. You are working with robots, which are some, like, they are not humans. Sometimes you have to communicate to them. It is really fun. And the most annoying thing, again, communicating to robots, sometimes they don't understand you. So you just try to build a system. Whenever you have some problems, it might be sometimes annoying.
Is it frustrating when the robot is smarter than you? No, joking.
No.
Just joking. How big is the testing team in comparison with the development team?
The testing team size?
Yeah, compared to the development team.
I guess it was around like 1/4 of the development team. Like we had 20 members in the development team and 5 members in the testing team.
Okay. Oh, what do you think? How near is it in the future that all big warehouses will use almost only robots?
I don't think it would be possible, at least in the near future, because it is just like an AI, artificial intelligence system. You can entrust and replace some manual effort with them, but I would say not 100%.
Okay. Can simulation be used to calculate the efficiency benchmarks?
Kind of, like we can run simulation for a long time. It will be kind of longevity test, and we can measure the metrics. But again, to collect some feedbacks directly from the end users, you still will need some manual testing as well on top of that.
Okay, one more short question, short answer. How well can a shipped solution be altered to handle physical changes in the warehouse layout?
This is why we use the cloud platform. But you said physical changes.
Yes.
Yeah. So yeah, for physical changes, of course, you can teach the manual operators, or there are some warehouse managers. You can guide them to apply, but if it is not possible, then probably we should do by ourselves.
You were really great. Thank you so very much. Ladies and
Thank you.
gentlemen, Mesut, one more big applause. Really, really thank you.
Thank you.